Hey, this would be a good opportunity to start talking about undetermined coefficients and kind of a guess and check method. So I was thinking about this DE. Last night. This linear first order DE. And I went ahead and as I'm lying there, I solved it in my head and realized, that's kind of an interesting example. But then I thought, if you just glance at it, it should be obvious that the constant function y equals 1 is a solution. Because if y equals 1, then y prime equals 0, and we get cosine times 1 equals cosine. So I started thinking, I wonder if we could, without using an integrating factor, just figure out, kind of by guess and check, what the general solution is. And then we'll do like our normal method of integrating factors and actually generate the general solution. So let's kind of guess and check what we think the solution might be. Differential equations are hard. Derivatives are easy. If I hand you a function that's made up out of elementary functions, you're guaranteed you can take the derivative. It doesn't matter how nasty that function is. Taking the derivative is product rule, chain rule. That's really it. Remember, difference rule or quotient rule was just a different version of product rule combined with chain rule. So there are only a couple of rules, and you can always take the derivative. You can't always take the antiderivative. For example, this guy here has no antiderivative made up of elementary functions. You can try all day. You can't do this antiderivative and get things made up of powers of x, cosines, sines, exponentials, and logs. Differential equations are hard because they involve integrals. So most of the time in the real world, we teach you all these tricks in this class. Most of the time, if somebody hands you a DE, it won't fit any of these special patterns we've seen, and you won't be able to solve it. Or if there is a solution, you honestly find it by guess and check. So let's play around here and see if we can do that. Let's try to figure out what kind of function y would be so it would satisfy this. So I noticed this, so my next thought is, I wonder if y equals a constant would work. Like maybe y equals 5 might also work. But we see pretty quickly that doesn't work. Y prime would still be 0. And then if I plug this in, I would get c times cosine of x equals cosine of x. That only works for 1. So then you might think, oh, well, maybe our general solution, we've got to have this 1 in there. And we're going to learn later that if you have independent solutions to, say, a third order DE, that you can add up 3 different linearly independent solutions and have the general solution. So maybe we would think our general solution might be 1 plus a constant times, I don't know, maybe some power of x. That might be the first thing we would try. But again, we see pretty quickly, if I'm using powers of x, say even if I just tried y equals x squared, then the derivative would be 2x. So I'm going to have up here a 2x plus an x squared cosine equals a cosine. That's not going to work. Oh, maybe we can get something to cancel out if we did more like this. Maybe 1 plus x squared. Maybe if we throw in a minus in there, maybe we can get this term to cancel something over here, so we're just left with cosine. If we try it, y prime would be negative 2x. And again, it's not going to work out. The powers aren't going to match up. I'm going to get here something with an x in it, here something with an x squared, even when I distribute. If I take cosine times this, that x and that x squared are never going to cancel out. And the same would be true of any kind of power of x. Powers of x aren't going to work. They won't cancel out, leaving just a cosine. So then we might think, the first thing you should think really is, let's try some exponentials. Maybe like a constant times e to the x. Then y prime would be c e to the x. And again, it's not going to work out. We're going to have a c e to the x here, a cosine times e to the x here equal to cosine. There's no way I'm going to get rid of this guy here up here. So then you might try maybe sines and cosines. Maybe our general solution might look like, I don't know, c times sine. And then our derivative would be c cosine of x. And again, things won't cancel out. I get my cosine here, but I get this c in front of it that I don't have over here. When I distribute, I'm going to have a cosine times a sine that I don't have on the other side, and there's no way to get rid of it. So we're starting to see that whatever we put here needs to look like y and introduce a cosine that wasn't there to begin with. We need something. We definitely want this 1 plus, but whatever is going to add on here needs to be something that when we take a derivative, we pick up an extra cosine. So we tried sine, it didn't work. Maybe we'll think, oh, well, what if I did an exponential of something like this? Then when I take the derivative, I'll pick up an extra sign. Will that work? Well, I don't know. Maybe if I put a sign here. Then when I take the derivative, I'll pick up an extra cosine. Let's see if things work out. So y prime would be derivative of e to the anything is e to that same thing times the derivative of what's up top. So if I plug that here, I'll get c e to the sine x times cosine of x plus cosine of x times all of this. And I want to know, can I make that equal cosine of x? Well, when I distribute here, oh, if I only had a minus there, these two terms would cancel out. So, okay, let's change that to a minus. I distribute, I get c e to the sine x times cosine x plus cosine x minus c e to the sine x cosine x. That does, in fact, because these cancel, equal cosine x. So that will work. And we got there literally just by guessing and checking, by figuring out what kinds of functions would give us the right things in the right places. And that's what we're going to get. We're going to actually solve this the right way. This is what we'll get for our solution. I don't remember having that minus. Again, I did this in my head last night while I was trying to fall asleep. So let's see if that minus was correct there, but I think it was. Okay, this is a linear DE. So we can solve this using an integrating factor. Our integrating factor will be e raised to the antiderivative of the guy up here beside y. Antiderivative of cosine is sine. So that's my integrating factor, e raised to the sine of x. I'm going to multiply everything by that. Then, if I've done everything right, the left-hand side should be the derivative with respect to x of y times the integrating factor. So let's check and make sure that works. Product rule here, derivative of the first, leave the second alone. Leave the first alone, derivative of the second. There's the derivative of e sine of x. That's e to the sine of x. Okay, so it worked. We integrate both sides. Don't forget to put your little dx here on both sides. On the left side, we get y e to the sine of x. On the right side, this is an integration by substitution. U equals sine of x, du equals cosine of x dx. So antiderivative of e to the u is e to the u. Plus c. And then I want to divide through by this thing. So that will be 1 plus, if I divide through by that, that would be c over that, or c e to the negative sine of x. Okay, now does this match what I came up with by trial and error? Can I make this look the same? Remember, a negative in front of a constant is just a different constant. So I'm not too worried about having that plus. What about having that negative sign there? Can I incorporate that into the constant maybe? Well, remember e to the a times b would be, oh yeah, I'm not sure if I'm going to be able to incorporate that constant, that negative. Now that makes me wonder, because I like this, that makes me wonder if I should have had that negative when I was doing the trial and error instead of having a minus outside. Because I don't think I'm gonna be able to pull that negative out. So I tried oh, yeah, that was wrong. The derivative then, y prime would have been, when I tried that as my guess, I didn't put in this negative from the derivative. So that did not work. It was close, it was almost there, but it didn't work. That negative won't work if it's in front. It needs to be up here in this exponent to make things cancel out. So there is our general solution. Okay. One last thing I do want to point out, that having that cosine on the other side was imperative. If this had been, I don't know, let's pick anything. Let's pick even a constant. If this had been 5, then we would not have been able to solve this dE. We would have gotten our integrating factor, the same thing, e to the sine x dx. Then we would have gotten and then we would have to try to integrate this. I don't know the antiderivative of e raised to the sine of x. I don't know if there is a closed form solution for that. So remember, just because you can find an integrating factor, just because you can get to this step, doesn't mean you're going to be able to move forward. Sometimes what you get over here is just terrible.